Okay, so what we're going to do today, right now, we're going to work this example. We've been talking about kinetic theory, and so this is from your textbook. It's number 13 in chapter 12, and so we should be able to get this pretty readily. It's got 4 lines by it, which means it's supposedly a really challenging problem because these will, in your textbook, will go from 1 to 4 or 5. I can't think of 5 off the top of my head, but that gives the level of difficulty. So let's go ahead and read it. Many cultures around the world still use a simple weapon called a blowgun, a tube with a dart that fits tightly inside. A sharp breath at the end of the tube launches the dart. When exhaling forcefully, a healthy person can supply air at a gauge pressure of 6 kilopascal. What force does this pressure exert on a 1.5 centimeter diameter tube? Now, this is actually back from a previous chapter. This is basically pressure and force divided by area. So pressure is force divided by area. That is a standard equation from which we can start. We are looking for the force. That's what we want. So the force is going to be given as the pressure times the area. In this case, the area is the cross-sectional area, and that area is given as pi r squared. Well, I'm not given r, that's the diameter. So r is going to be 0.75 centimeters. It's half the diameter. So r squared is 0.75 squared times 10 to the minus 2, because that says centimeter. Crikey. Squared. And so r squared is going to give me, and I'm looking it up where I did it before, 5.625. 5.625 times 10 to the minus 5th. Well, let's go ahead and multiply that by pi r squared. And so I'm going to get my area, and I get 1.767 times 10 to the minus 4th meters squared. That should be in meters squared. Okay. So now that we have this situation happening, we have the area. We know that the pressure is given as 6 kilopascal. And we want this in SI units, so that's going to be 6 times 10 to the 3rd pascals. Make sure you're always taking your information and putting it into SI units before you start. It does make your life so much easier to do that. And so my force is now going to simply be 6 times 10 to the 3rd pascals, or newtons per square meter. That's a pascal. Times 1.767 times 10 to the minus 4th meters squared. Notice that my meters squared cancel. Woo-hoo. And I am going to be left with 1.06 newtons. That's it. That's all that you need to have for this problem. Hopefully this gives you a little bit more insight, and we'll be catching you on the next side.